Okay, so let's see what we can take care of in this video. We're going to jump in to a totally different style of problem coming up, where we're actually just finding out where a couple of things happen. So we're going to find out where the sine of 2 theta is the same as negative 2 cosine theta. So the first thing to note is we've got a double angle here and a single angle here, and that mathematically is kind of not a good thing because they're almost like variables and they're almost different. And so what you want to remember is that the sine of 2 theta is 2 sine theta cosine theta. That's one of our little identities that we established. And one of the temptations that people will want to do is they'll want to divide both sides to make that cancel out. But that's a real big mistake, because you can't divide by 0, and the cosine, in fact, is 0 if you kind of follow us down to the very ending of the story. So instead of dividing, what I choose to do is I move everything to the same side together, because as long as I can do that, then I can factor. And I notice that these both have a 2 in common, and they both have a cosine in common as well. So if I factored out a 2 cosine, all that would be left in this front piece when I took out the 2 and the cosine is that sine. And then when I took out the 2 and the cosine left, I have a 1. So the zero product property means the only way that the product of 2 cosines and this value here is 0 is if either one of those is 0. And that would happen if specifically the cosine was 0 or if the sine was negative 1. And so going to our unit circle, remember on the unit circle, this coordinate is 1, 0. This one is 0, 1, negative 1, 0, and 0, negative 1. You want to remember that when you're looking for zeros and negative 1s, those are quadrantal angles, which are kind of hard to say. But when the cosine or the x value is 0, happens at these 2 locations. And again, I only care about the first wrap around the circle, so it happened at 1 pi over 2 and 3 pi over 2 would be the 2 theta values that make that true. Pi over 2 and 3 pi over 2. And then when the sine, which is the y value, is negative 1, is down here, that happens at 3 pi over 2. And so if you're going to make a list of answers, you'll notice that we have the same answer twice. So we don't bother to list it twice. We're just going to say, hey, that happened at pi over 2 and 3 pi over 2. Now, we're going to do this in the next example. Looking for where my calculator went, in a different scenario, but I'm going to go ahead and take advantage of this real quick and just ask about the sine of 2 theta. But of course, I can't use theta in this case. We're going to learn a little bit about the theta button that's sitting there, but later in another unit. And negative 2 cosine. On window, it told me to go just from 0 to 2 pi. And we should know that sine and cosine waves only go up and down between 1 and negative 1. So in this case, it might be a little bit bigger, but it won't go above or below the number 2, according to this. So if we graph this, I should see my sine of 2 theta. I'll see 2 perfect sine waves, and here comes my 2 cosines, and I'm going to see 2 points of intersection in here, one over here and one over here. And so we could calculate that intersection. And this was the little trick that I taught you guys in class, is when I find that intersection, 1.57, kind of a weird number, but I can take that answer, divide it by pi, math, enter, enter, and notice it says 1/2, or in other words, pi over 2. And of course, if I decided to calculate that other intersection right here, I'm pretty sure we're going to pull 3 pi over 2 as well. So moving on, when we look at letter B here, it's asking where are those equal. Well, the first thing that jumped out at me is that is a number 1. And normally I like to set things equal to 0, but this problem is actually rigged up to do something a little bit different. I'm going to move the 2 to the other side. I'm going to divide both sides by negative 2. And this is actually a problem right off of one of the previous worksheets that we had. But if we take the square root of both sides, this is a little bit interesting. Not everybody understands this, but the square root of 1, of course, is 1. That's not a big surprise. And the square root of 2, well, this is plus or minus root 2 over 2 if you rationalized it. And that is going to be all of the pi over 4s. Because not only do I want the two places where the sign is positive, which is at 3 and 1 pi over 4, but I also want the two where it's negative, right here at 5 and 7 pi over 4. So again, I could graph this thing, but we know that those are going to be the answers that come out to play. So moving on to number 7, question number 7 takes us a little bit further, where we're going to just completely use nothing but the calculator to do that. And that means we're going to follow our directions. I'm going to find out, what does 5 sine theta look like? Well, right away, I know that that graph goes as high as 5 and as low as negative 5, minus 3 cosine. So now it's going to be mixing with something else of 3x. Actually, shouldn't put that 3 there. And I want to know, when is that equal to negative 4? And notice it says on a window from 0 to 2 pi. So again, I go to my window, I have 0 to 2 pi. But since the amplitude of this wave is 5 and I'm adding something to it, I'm going to go ahead and give it a little bit more room. And actually, negative 6 and positive 6 would have been enough. But let's just see what happens. So here comes my my weird wave. So it is a periodic function. It does do something, but I want to know, where are these two places, which of course those are going to be measured in radians. So if I calculate the intersection, remember we said second calc number 5, enter 3 times, and it's going to zero in on this value of 3.886. So theta equals 3.886. And the other one, of course, would be, let's see, let's get a little closer here. Enter 3 times, and it says 5.010. And again, I don't need to write radians because radians are understood. Now, you'll notice that there's no work to show because I did all of it on my calculator. So what I tend to do when I'm doing problems like this is I will sketch very roughly what it is that it looked like that I did, and I found those two values, so that if I did something wrong, the teacher would go, oh, you probably made a mistake in this place, but I know. But if you just write down answers, there's no way to know. Now, you'll notice that there's a switch here. This is something we don't do very frequently. It actually told you to go to degrees. So in my mode, let's go over here to degrees, which means my window is not going to be 0 to 2 pi, it's 0 to 360. Now, my calculator, again, does not have a cosecant button, but it does have a sine button. So remember that a cosecant is 1 over the sine. So I'm going to do 1 over the sine of x. And I just created a cosecant. And then it says plus 4, and I want to know, when does that intersect, make sure that I have that closed off correctly, I do, equal to negative 2. And again, window-wise, I'm not exactly sure how big this go, but remember the cosecants go up and down like these big U's, and this is a fairly large number in front. So I guess I'll just give it a little more room just to make sure I don't miss it. But here comes my cosecant wave, and obviously I'm missing a lot of the top, but it doesn't matter because I'm interested in what happens down here. So as a quick sketch, I saw that I have some kind of a U up here and another one down here, and I'm looking for these two values, the places where those crossed. So we're going to go ahead and calculate that intersection. And for the sake of time, since I showed you that in the previous example, I'm just going to write this one down. I'll just find 1. Now you're going to notice that it's going to eventually pop up. So one of my answers is 236.442 degrees. And my second answer is going to be 303.557 degrees. And we can kind of just leave it there. And there's not a lot of work to show because I let my calculator do the math for me. So just to try to keep the number of videos down, I'm going to go ahead and jump on number 8 and add this one. The number pi and 3 pi over 2, here is pi, here is 3 pi over 2. So this is actually telling me to draw my triangle down here, where the cotangent, which is adjacent over opposite, is 8/15. Now Pythagorean triple, or we could use the Pythagorean theorem if we needed to. That side is going to be 17, but we do want to remember that these both go left and down. The second triangle, which is of course our beta triangle, is has a positive cosecant but a negative tangent. So it's sitting over here, and it has a cosecant, which is hypotenuse over opposite. Those are both positives because this is up. And I got negative root 39 from Pythagorean theorem. So for me, what I did is I just jumped in there and I said, I don't really want to deal with you. So I'm going to deal with the sine of alpha plus beta, which is sine cosine plus cosine sine. So I need to go fetch all four of these ratios. I need the sine of alpha. I need the cosine of beta, that's adjacent over hypotenuse. I need the cosine of alpha, and I need the sine of beta. So I keep going back and forth. And so as we go through this entire process, we have a pretty nice little story that is positive because it was a negative times a negative. That's 15 roots of 39. And over here, we had a negative 40 over, both of those have a nice little denominator of 136. So that's pretty good. So I could say 15 roots of 39 minus, meant to say minus there, minus 40 over 136. So that would tell me then my cosecant would be 136 over 15 roots of 39 minus 40. Not a nice answer, but a legitimate answer nonetheless. And then my last one, of course, is the tangent of alpha minus beta. We go ahead and write our formula in. And this is a hard part for a lot of people about the tangents, is when you subtract in the tangent, you have a minus on top and a plus in the bottom. So the only reason I even think this problem is worthy of the mention is that when you get in here and you do all of the work, you do get some fairly obnoxious looking numbers. Because you've got 15/18, but then you've got this denominator of 5 over root 39. That's terrible. And then you have the same two right here, because remember, these are both tangent alpha and these are both tangent betas. So I saw that and I didn't really like it. So I'm going to multiply the top and bottom by 8 roots of 39 to simplify it ever so slightly. And you're going to notice that when this multiplies over here, the 8s would cancel and you get 15 roots of 39. I saw a double negative here. And then the root 39s would cancel and I get 40. And in the denominator, of course, 8 roots of 39 times 1 is going to be 8 roots of 39. And then these would entirely cancel with all of that. And we're going to have minus 75. And that's the end of question number 8, which kind of finalizes that story. So that'll end this particular sorts of questions. Bye-bye.